Okay, to continue the series of questions on our reviews, let's just take a look at numbers 7 and 8, see if we can talk about factoring when we have some complex numbers, as well as looking at a little bit more of an accurate share of a graph. So here we go. Right away, if we're going to find the linear factorization of this is kind of weird. So in my final answer, we have to know that the linear factorization means we're going to have x minus each of these roots. So according to what they have given me, I already know that 2 minus 3i is a root, but I also know that 2 plus 3i is a root. So that's a really ugly looking way of writing a linear factorization, but that's part of the answer, and I didn't have to do any work to get that. Now, we had two options on how we played this game that we did in class. One of the ways that we did this in class is we took the original polynomial right here, and since we knew that the problem was divisible by both of these, if I could turn this into a simple quadratic, x squared, remember when we add those together we get 4 because the i's would cancel, and so we did a minus 4x. And then, of course, if we square both of those coefficients, which are 4 and 9, we get 13. Now, if we take the time to go through this process and divide each of those out, remember, to get this, we need an x squared. We kind of multiply this down. Plus 13x cubed. We come through, we change our signs, and we add. Now, I'm going to go ahead and stop this pretty quickly because I know that it does take kind of a long time to go through this process. But if you were to continue this process down the line through what we are doing, you would get a negative 2x and you would get a minus 3. I can show all of those steps, and in fact, I think what I'm going to do is I'm going to pause, going back to that video. Here we go. See, it actually did work, and that's kind of what popped in. And I know some of you guys liked that, but some people did not like that. So we also looked at it through a slightly different lens. We also looked at it like, what happens if we divide by 2 plus 3i synthetically? This is one of the reasons I really honestly wanted to make this video, because we had only done this together in class one time, and I know that that's hard to make things stick when you go that quickly. So what I had you guys do in class is we took 2 plus 3i and we stored that as a. Now, since we have that, if I took this a and I multiplied it by 1, I would get this 2 plus 3i that's already sitting here. So I need to minus 6. This is again going to be multiplied by a. Let's add that 18 to that, and I get 1 minus 6i. Let's multiply that by a again. Subtract 14 from that, and if I have done well, then I hope I get a positive 39 right here, because it's going to cancel that out. And in fact, I did. Now, the cool thing about that is if we know that 2 plus 3i works, then so does 2 minus 3i. And this is what's kind of nice about this, because on the last step here, we don't really need our calculator anymore, because this multiplies to 2 minus 3i, and notice how the i's cancel. Then we multiply those together, and notice again the i's cancel. And at the last step, you get a negative 6 plus 9i, which everything cancels. And notice the confirmation that we got an x squared, a minus 2x, and a minus 3. But that's awesome, because that's a super easy thing to factor, because x squared minus 2x minus 3 is x minus 3 times x plus 1. So this is the linear factorization, and it's linear because none of these terms are squared, but we have the linear factorization of the problem. Now, in terms of number 8, that's going to be a quicker problem. There's not a ton that we need to do on that question, but our roots are at 2 with multiplicity 2. That tells me at the number 2 I'm going to have a little parabola going on. there's a root at 1/2 whose multiplicity is 1, which means it's going to come through like a little line. And at -1, it's going to have multiplicity 3. So I'm going to have a little cubic. Now, as far as end behavior, if I multiplied this whole thing out, I would get basically some kind of a negative leading coefficient multiplied by x to the 2, 3, 4, 5, 6. So when we're all said and done, that means that if we have the end behavior, which if we write it carefully, the limit as x goes to infinity on f of x, because that's the name of the graph, or as I go to negative infinity, if it is a negative and it is an even power, that means both the right side and the left side are going to go down. So I think we can kind of figure this out. It's going to be down on both sides. I have a root of 2, a root at 1/2, and a root at -1. I think I put that in the wrong place, didn't I? So we got a root at 2, a root at +1/2. Now, since this root at 2 is of multiplicity 2, it's going to have to be some kind of a down curve here. The number at 1/2 was coming up like a line, and then the one at -1 is going to be some kind of an S curve. Now, the only thing that I would have left to do is maybe test 1 or 2 numbers. So what I did is I actually found out what was f of 1. And I literally just went up to the original problem and I plugged the number 1 in, and I actually got -4, which was pretty simple. So 1 gave me -4, so I could kind of play connect the dots. And I don't know if it goes a little bit lower than that or not, but I'm trying to emphasize that it may or may not be the minimum right there. And then, of course, what a lot of people would want to do inside of here, you might try, like, say, 0. And when I tried 0, I got the number 2. So it's going to come through 2 right here. So again, it's going to come up like this. And then, of course, once it goes through the final one of these roots, it goes down towards infinity at a very, very rapid pace. Now, it actually says to find 2 extra roots in between those. But that I just got 2 points, and I think that's going to be sufficient for this particular video. If I wanted to plug in -1/2, that might be nice. If I plugged in 1.5, that might be nice as well. Again, I could plug those into my calculator and then go to the table feature and come up with some nice easy values. So that gives us those couple of problems, and we'll have one video left to go, which is going to get us through the last page. So hopefully this is helpful.